Okay, P6 notes, we're going to be talking about factoring. The notes are going to be split up into 3 parts. So we're going to have a part 1, part 2, and part 3. At the end of each day, each part's going to be due. At the end of each class period, each part's going to be due as a classwork assignment. So make sure you complete them and turn them in. So we have a couple tips at the top for when you're factoring. Always look for GCF first. So GCF is going to be the first step. See if you have any common factors. It'll either make the next step of factoring easier, or that might be the only thing that you have to do. We're also going to look at factoring basic trinomials today when A is 1. And then we're also going to be grouping today. So we're going to look at those 3 types of factoring today. So first type, it says the easiest type of factoring occurs when we have a common factor. So that's why we always want to look for that GCF first. So we're going to look at example A on the bottom. It says factor each expression. We want to see what common factors 3x squared and 6x have in common. So we always want to look for the number first. We want to see what number goes into both 3 and 6 if they have any common factors. So we can divide both 3 and 6 by 3. And then let's look at the x's. We have 2 x's in the first term and 1 x in the second term. So they at least both have 1 x, so I can take out an x. It's going to be the smallest amount of x's that they have in common, or the smallest amount of that variable, because I can't take out 2 x's if I only have 1 x. So I'm going to take out a 3x. What you take out, your GCF is going to go on the outside. Don't forget to put that in your answer. And then we're going to divide each factor, each term, by that 3x. So the 3's cancel, and then if I have 2 x's on top and I take 1 away, it's just like subtracting with our x's. So it would be 2 minus 1, which would just be 1x. And then we do the same thing here. I'm going to divide 6 by 3, so that would be 2. And then the x's would just cancel. So my answer would be 3x times x minus 2. We're going to do the same thing with b. We have 3 terms here, so we have to look and see what's common in all 3 of our terms. Starting with the numbers, we see that all of them are divisible by 2, so I can take out a 2. So that's going to go to the outside. Next, looking at the x's, I have 4 x's in my first term, 3 in the second, and 1 in the third term, so I can take out 1x. Remember, it's going to be the smaller one because I can't take away 3 x's if I only have 1x. So I'm going to take out an x. And then with the y's, I have 2, 3, and 4, so I'm going to take out 2 y's. So y squared. Now let's simplify. So I'm going to simplify the numbers first. 8 divided by 2 would be 4. Taking out 1x from the 4 would leave us with 3 x's, so x cubed. And then I have 2 y's, and I'm taking 2 away, so the y's cancel. Then plus, moving on to the next term, I'm going to divide the numbers first. So 6 divided by 2 would be 3. If I have 3 x's on top and I'm dividing 1 out, that would leave us with x squared. If I have 3 y's on top and I'm taking away 2, that would leave us with just 1 y, so just y. And then moving on to the third term, we have a minus sign. 2 divided by 2 would just be 1. The x's cancel, and if I have 4 y's on top and I'm dividing 2 of them out, that would leave us with 2y, so y squared. So this would be our final answer. You can always, for either one of these, A or B, for any question like this, you could distribute the GCF back out and you'd end up with the original question. So again, here you could distribute the GCF back out and you'd end up with the original. But that would be like working backwards just to check your work. So you could check your work that way. And now let's look at C. First thing we want to do is check and see if we have a GCF. Also, we always like it when our leading coefficient is positive because it's going to help us with factoring later. So I'm going to make sure that whatever number that I divide, my GCF is going to be negative, which will turn that first negative term into a positive. So we want our leading coefficient to be positive. So looking at the numbers, each one of these terms is divisible by 5, but I'm going to take out a negative 5 just so I can flip that sign of my leading coefficient. And then I have 4 y's in the first one, 3 and 2, so they all have at least 2 y's that I can take out. So I'm going to take out a negative 5y squared. So I'm going to write that on the outside. And then we're going to simplify. So negative 15 divided by negative 5 would be 3. Y to the 4th power divided by y squared. I'm taking 2 y's away, so that would be y squared. Then 5 divided by negative 5 would be negative 1. And y cubed divided by y squared would be y. We don't write 1y, so I'm just going to get rid of that 1. Just leave it as y. When our coefficient's 1, we don't need to include it in our answer. And then negative 10 divided by negative 5 would be positive 2. And I have 2 y's, and I'm taking 2 away, so they cancel. I'm left with no y's there. So this would be our final answer. This can actually factor more, but we're going to talk about how to factor when our leading coefficient's not 1 in part 3. So we're just going to leave it like this for now, but in the future we'll have to make sure that we factor all the way. Right, next, let's look at example 2. So again, we're factoring out a common factor. So we want to see in these two terms, remember terms are separated by a plus or minus, so we have one term here and one term here. In these two terms, what do they have in common? So they both have an x minus 3. So I'm going to take out an x minus 3. I'm dividing both of these by x minus 3, just like we did in the last one. It's just not an x or a number that we're taking out. We're taking out that whole thing, x minus 3. So then we're dividing both of these by x minus 3. They go away, and we're going to be left with 2x plus 4 minus 5. Now we can combine these like terms inside here, so it ends up being 2x minus 1, because 4 minus 5 would be minus 1. So we have x minus 3 times 2x minus 1. All right, for example 3, we're going to be factoring when our leading coefficient is 1. So we're not going to have any number out front, so this is just basic factoring. So looking at number 1, we want to ask ourselves, what are 2 factors of negative 48 that add to our middle term, which is negative 2? So we want to think factors of 48 would be 1 and 48, and 2 and 24, 4 and 12, 6 and 8. So we're looking for them to add to negative 2, so we would want 6 and negative 8. So once we find our factors, we write it as x plus 6 and x minus 8. They keep the same signs as the numbers that we have here. So the plus goes with the 6, the minus goes with the 8, and then we are done. Now we're going to do the same thing for number 2. We want to ask ourselves, what are 2 factors of negative 30? So multiply to negative 30, but add to negative 1. So if we need to, we can write down all of our factors. We have 1 and 30, 2 and 15, 3 and 10, 5 and 6. So 5 and 6 would work. We need it to be a negative 1, so the bigger number is going to be negative, so negative 6. So 5 and negative 6. So we would write this as, our variable here is y, so y plus 5 and y minus 6. And the order that we write it doesn't matter. If you wanted to, you could say y minus 6 times y plus 5. These are the same thing. Same thing for number 3. Again, we're looking for factors of 30, so multiply to 30, but add to 17. So we just wrote our factors of 30 here. So perfect, we know that 2 and 15 are going to add to 17. So we would write this as x plus 2 and x plus 15. For number 4, same thing, we want to find two factors of negative 27, so multiply to negative 27 and add to 6. So we can write down our factors of 27, it'd be 1 and 27, 3 and 9. So 3 and 9 would work. We're looking for positive 6, so the bigger number is going to be positive. It means the smaller number is negative. So 9 and negative 3. I could say negative 3 and 9. Again, the order does not matter. So this would factor into y plus 9 and y minus 3. And then last one on this page, number 5, we're looking for two factors of negative 50 that add to negative 23. So we can write our factors out. We've got 1 and 50, 2 and 25. 2 and 25 works. We're looking for a negative 23. So the bigger number is going to be negative. So 2 and negative 25. So this factors into x plus 2 and x minus 25. Example 4 is going to be part 3 that we'll do on Monday. Example 6 is actually going to be part 2 that we'll do tomorrow. So we're going to jump ahead to the last slide. We're going to look at factoring by grouping. So that'll be the bottom here, example 11. So we're going to factor by grouping. So we can group when we have at least 4 terms. We'll usually see it with 4 terms, but it could end up being more, like we could have 6 terms. We need at least 4 to factor by grouping. So if you have 3 terms, you know you cannot group. Anytime you have 4 terms, the first thing you want to do is look and see if you can group them. So when we factor by grouping, we group the first 2 terms and we group the second 2 terms. So once we group them, we want to look for our GCF in each group. So in my first group here, my greatest common factor would be x squared. So I'm going to take out an x squared, we write that on the outside. And then when I divide out the x squared, I'm left with x plus 1. Be careful here. We have x squared divided by x squared. They cancel, but we're still left with that 1. It doesn't just go away. You need that 1 in your answer there. Next, we want to look for our GCF in the next group. 4x and 4 are both divisible by 4. So our GCF is 4. That goes to the outside. We're left with x plus, again here, the 4's just don't cancel and go away. 4 divided by 4 is 1. Once we take out our GCF, the next step, the inside parts have to be exactly the same in order for this to work, in order to factor by grouping, because they go together as one piece. So we have an x plus 1 in our first parentheses, and then the outside parts go together in our second parentheses, x squared plus 4. So the 2 inside parentheses have to be the same, and they go together into one parentheses, and then the 2 outside parts will go together in the other parentheses. So our final answer is x plus 1 times x squared plus 4. So let's look at B. Again, we have 4 terms, so we want to factor by grouping. Group the first 2, group the second 2. We want to look for our GCF in each group. So in our first group, we can take out an x squared. So that's going to go to the outside. When we take out an x squared, we're left with x minus 2. Then our GCF in the second group, could be 3. So if we take out a 3, we're left with negative x plus 2, which would make these two inside parts not exactly the same. So we may have to take out a different GCF because we need the insides to be exactly the same. So I probably took out the wrong GCF there. So looking at the second part, we can take out a negative 3, which would flip the signs and give us the same inside. So I'm going to take out a negative 3, and we're left with positive x minus 2. So now that our inside parts are the same, we're going to group those together in our first parentheses, x minus 2. And then the two outside parts are going to go together in the second parentheses, x squared minus 3. And that would be our answer. We're going to do the last 4 on the last page. So looking at number 1, we have 4 terms, so we want to factor by grouping. Group the first 2, group the second 2. In this question, it's actually missing, it should be a plus here in the middle. So it's just missing that plus sign. So in our first group, we want to take out our GCF. So that would be looking at the numbers, they're both divisible by 3. And then looking at our variables, we can take out an x squared. So 3x squared is going to go on the outside. 12 divided by 3 would be 4. And if I have 3 x's and I take 2 away, I'm left with 1. And then 9 divided by 3 would be 3. If I have 2 x's and take 2 away, we're left with no x's. Now in our second group, we don't have a GCF. So we would just leave it as 4x minus 3. Now our inside parentheses are exactly the same, so those are going to go together, 4x minus 3. And now the outside parts for this one, it's a little bit tricky because we want to take the outside here and the outside here. When we don't have anything written on the outside, it's implied that it's a 1. So inside my parentheses for the second piece, I'm going to put 3x squared plus 1. We need that 1 there. It's not going to be plus 0. You need the 1. So if you don't have anything written outside, if you didn't take out a GCF, that would be a 1 that goes in that spot. Now let's look at number 2. So we're going to group the first 2, group the second 2. Take out the GCF from the first group, that would be an x squared. So x squared is going to go on the outside. And then we're left with 2x plus 5. Then in our second group, we're going to take out the GCF, which is 3. 3 goes into both 6 and 15. So 3 is going to come to the outside, and we're left with 2x plus 5. So now that our inside parentheses are exactly the same, those go together in your first group. And then the 2 outside pieces will go together in your second group. So our answer is 2x plus 5 times x squared plus 3. Looking at number 3. Again, we have 4 terms. We're going to factor by grouping. Group the first 2 together, group the second 2 together. GCF in our first group is going to be a y squared. So I'm going to take out a y squared, and I am left with y minus, the y squareds cancel each other out, but it doesn't go away. We need that 1 in that spot. So y minus 1. And then we're going to do the same thing with the second group. Take out our GCF, which would be 2. So 2 goes to the outside. When we take out a 2, we're left with y minus, again, the 2's cancel, but they don't just go away. We need that 1 in that spot. In your parentheses, if you have 2 terms, you divide out a GCF, you're going to be left with 2 terms on the inside. You need that 1 there. Now that our inside parts are exactly the same, we're going to put them together. and then the two outsides go together into our second piece. So y squared plus 2 times y minus 1. Again, for these, the order doesn't matter if you wanted to write it y squared plus 2 times y minus 1. These are the same thing. They are both correct. Order does not matter. Last one, let's look at number 4. We're going to group the first two, group the second two. Take out the GCF from the first group. We have a 5 that goes into both 5 and 10s. We're going to take out a 5 and a y squared. So 5y squared goes to the outside. We're left with y minus 2, because 10 divided by 5 would be 2. The y squareds cancel. And then we take out the GCF in the second group, which would be 3, because 3 goes into both 3 and negative 6. So when I take out the 3, I'm left with y minus 2. Our inside parentheses are exactly the same, so they go together. And then the outside parts go together too. If your inside parentheses were not exactly the same, then you took out the wrong GCF, or you can't factor by grouping. So the inside parts need to be exactly the same in order to group it to become 1, and then the outsides go together. So our answer here is y minus 2 times 5y squared plus 3.